the gas law's Avogadro law volume amount relationship. Avogadro's law, sometimes referred to as Avogadro's hypothesis or Avogadro's principle, is a gas law. It states that under the same pressure and temperature conditions, equal volumes of all gases contain the same number of molecules. The law is named after Amedeo Avogadro, who in 1811 hypothesized that two given samples of an ideal gas of the same volume and at the same temperature and pressure contain the same number of molecules. Thus, the number of molecules or atoms in a specific volume of ideal gas is independent of their size or the molar mass of the gas. For example, 1.00 liter of N2 gas and 1.00 liter of Cl2 gas contain the same number of molecules at standard temperature and pressure STP. Avogadro's law is stated mathematically as V is equal to K N. V is the volume of the gas, N is the number of moles of the gas, and K is a proportionality constant. As an example, equal volumes of molecular hydrogen and nitrogen contain the same number of molecules and observe ideal gas behavior when they are at the same temperature and pressure. In practice, real gases show small deviations from the ideal behavior and do not adhere to the law perfectly. The law is still a useful approximation for scientists, however. Significance of Avogadro's law: discovering that the volume of a gas was directly proportional to the number of particles it contained was crucial in establishing the formulas for simple molecules at a time around 1811 when the distinction between atoms and molecules was not clearly understood. In particular, the existence of diatomic molecules of elements such as H2, O2, and Cl2 was not recognized until the results of experiments involving gas volumes was interpreted. Early chemists mistakenly assumed that the formula for water was HO, leading them to miscalculate the molecular weight of oxygen as 8 instead of 16. However, when chemists found that an assumed reaction of H plus Cl give HCl yielded twice the volume of HCl, they realized hydrogen and chlorine were diatomic molecules. The chemists revised their reaction equation to be H2 plus Cl2 give 2HCl. When chemists revisited their water experiment and their hypothesis that HO gives H plus O, they discovered that the volume of hydrogen gas consumed was twice that of oxygen. This meant that hydrogen and oxygen were combining in a 2:1 ratio. This discovery led to the correct molecular formula for water, H2O, and the correct reaction, 2H2O gives 2H2 plus O2.